This is section 10.5, part 2, multiplying with more than one term and rationalize denominators. I'm actually not going to go through this whole packet today because I think after looking at it, I think we need to split this up into another part. And so I'm going to make a part 3. So today, our objective is just to go through rationalizing denominators containing one term. We will do number 4 in the next section. So let's look at a couple examples. Rationalizing denominators. All rationalizing denominators means is we've got to get the square root off the bottom of the fraction. Square root out of the denominator. It's got to be rational. That's what that means. And square roots are not rational. So what you do, because it's a square root, and what cancels out a square root is a squared, you just take this in this first problem, square root of 5 divided by square root of 6, and you multiply by the same number, square root of 6. And that looks horrible, because multiplying square root of 6 by the square root of 6 is the same as taking square root of 6 and squaring it. But whatever we do on the top, we got to do on the bottom. Or whatever we do on the bottom, I should say, we got to do on the top. So square root of 6 times the square root of 6 on the bottom. And on top it would be square root of 5 times the square root of 6. So what you get when you do that, 5 times 6 is 30. On top you get the square root of 30. On bottom you get the square root of 36, which the square root of 36 is just 6. So you can kind of figure out if I'm going to multiply the bottoms by the same number, or if I'm going to square it, I'm just going to get that number back. Cubes are a little different because you can't just multiply the cube by itself, because cubes take 3. It takes 25 times 25 times 25 to be a cube root of 25, to take a cube root of that, or to get a cube root answer of 25. You guys understand what I'm talking about. You gotta have 3 terms, and with squares it's just 2, so you can just multiply it by itself. So first of all, we can rewrite this as the cube root of the top over the cube root of the bottom. The quotient rule says we can do that. And then we're going to have to find a perfect cube that 25 goes into. Well, it just happens to be 125, and in order to get a 125, we're going to have to multiply by the cube root of 5. When I multiply the cube root of 25 times the cube root of 5, I get the cube root of 125, and that'll work. But I also got to multiply the top by the cube root of 5, and what I get is the cube root of 35 on top over the cube root of 125 on bottom. And the cube root of 35 is not going to reduce, so that's going to stay as the cube root of 35. And on bottom, the cube root of 125 is just 5. So pause here, try your checkpoints. When you come back, I'll give you the answers. Alright, checkpoint 3A. The answer is the square root of 21 over 7. And B, the answer is the cube root of 6 over 3. Let's move on to the next example, example 4, rationalizing denominators. Alright, so 4A, we're going to rationalize each denominator. You're going to start off, we got the square root of 3x over 5y, and we're going to separate it out so that it's the square root, let me get my, there we go, square root of 3x divided by square root of 5y. And since it's square root, super easy, all you got to do is multiply, to rationalize the denominator, you multiply by whatever is in the denominator under the square root of 5y, and multiply it on top and on bottom. So on top we're going to get the square root, and we can multiply the 3 and the 5, that's 15, and xy. get that xy, okay, and then on the bottom I'm just going to get the square root of 25y squared when I multiply them, and 25y squared is going to reduce to 5y, so the square root of 25y squared, so I'm going to get the square root of 15 xy over 5y. And that's our answer. In B, cube root. The cube root of 36, you can't take the cube root of 36. So we need a number that 36 will go into that is a perfect cube. Well, that number happens to be 216. And 36 times 6 makes 216. So I'm going to multiply top and bottom by the cube root of 216. Now the y, I've got to make a y cubed. So I can't just multiply by y, because y times y is going to make a y squared. I need it to be y cubed so I can take the cube root of it. So I need to multiply by y squared. So the cube root of 216y squared. So what do we get? On top, I'm going to have the cube root of 216. Oh, no. I take this back. 216 is what I want. I'm doing this wrong. Sorry. I apologize. I want to make it 216. So I have to take 216 divided by 36. I'm going to multiply, and that comes out to 6. I'm going to multiply by the cube root of 6y squared on top and bottom. And that's going to become 216 on bottom. On top, it'll be the cube root of 6. I'll put the x after that, and then the y squared. On bottom, it's going to be the cube root of 216y cubed now. And so I can reduce the bottom. I got 6x y squared on top. And on bottom, the cube root of 216 is 6. And the cube root of y cubed is y, so I got 6y. And that's the answer for B. In C, the fifth root. Well, fifth root, the first perfect fifth root is 32. And I just got to see 4 goes into 32 if I multiply it by 8. So I can make a 32 out of the fifth root of 4 times 8. And then x cubed, I need it to be x to the fifth now because I got to divide by 5. So that's going to be x to the second, because 3 plus 2 is 5, and y to the fourth, because I need that power on that y to be 5 too. And I'm going to multiply that on top and on bottom. 8x squared y to the fourth. What I get when I multiply the 10 and the 8, I can't multiply the 10. The 10y doesn't have a fifth root, so that's just going to be in front. 10y. Fifth root of 8x squared y to the fourth. On bottom, I'm going to get I can multiply the 8 and the 4, so I'm going to get the fifth root of 32. Oops. Fifth root of 32, x to the fifth, y to the fifth. So I can rewrite my top, 10y, there's nothing changed there yet. 8 x squared y to the fourth over fifth root of 32 is 2, fifth root of x to the fifth is x, fifth root of y to the fifth is y. But I'm not done, because now I don't have a fifth root on the bottom here at all. There's no fifth root down here, so I can divide the 2 and the 10, and I can divide the y by the y. So we're going to do a little bit of canceling out. And I'll cancel out in red here. The y's will cancel out. So the y's will go away. And the 2 is going to become a 1 because 2 goes into 10 5 times. So what I get in the end is 5 fifth root of 8 x squared y to the 4th all over just an x. And that's the answer. Pause here. Try your checkpoint. When you get done, I will give you the answers. So checkpoint 4, the answer to A is the square root of 14xy.
Caitlin Wood, report to the office. Caitlin Wood, report to the office.
Sorry about that. Over 7y. And B is the cube root of 3xy squared over 3y. And C is 3 times the fifth root of 4x cubed y over y. That's all we're going to do in this section. I know you have more. I'm going to save that for a 10-5 part 3. So I'm going to make a 10-5 part 3 and do that. I'll see you tomorrow.